Okay, in continuing with systems of differential equations that have initial conditions. Now for this particular system, we're going to have complex solutions. So I'm putting up just some references in advance. Okay, now we have from the Euler equation, you have e to the I times the angle is equal to the cosine of the angle plus I times the sine of the angle. And we have also just dealing with powers of I, have I to the first equal to I squared is equal to -1, I cubed is equal to -I, and we have I to the fourth is equal to 1. All right, now working with what we have in this system. Now we have x1 prime is equal to x of 1 minus 2 times x of 2. And we have the second order derivative of x of 2 of t is equal to 2 times x of 1 plus x of 2. And we have included initial conditions whereupon whenever t is equal to 0, we have x of 1 equal to 0 and x of 2 equal to 4. Now, again, for the system, just looking at it from the vantage point of establishing or at least a general solution, again, we can apply the coefficient matrix where we have going by each column. The first column we have 1 and 2. Second column we have -2, 1. Again, we have with the identity matrix, where the two equation system, we have 1, 0, 0, 1. And looking at what we have for the eigenvalues, again, we have for the determinant of a minus lambda I. Again, we have equal to 0, and we have in the setup, okay, so we have 1 minus lambda. We have -2. For the second row, we have 2 and 1 minus lambda. And for what we have in applying, okay, so we have, again, so we have 1 minus lambda times 1 minus lambda. And we have minus the product of 2 and -2. And once we multiply out and combine like terms, so we have lambda squared minus 2 lambda, and what's going to be plus 5 is equal to 0. And if you were to apply the quadratic formula, what you would have in effect is that we have for lambda, you can have your a at 1, b at -2, c at 5. So you'd be looking at 2 plus or minus the square root. Okay, and you have b squared is -2 squared, which would be 4. You got minus 4 times 1 times 5, so you have minus 20. You have over 2 times 1, which will be 2. So we're looking at 2 plus or minus. Okay, and we have the square root of -16, which will reduce to 4i. We have divided by 2. Okay, so we have 1 plus or minus 2i. And we have for the eigenvalues. So we have, so we just say we have lambda 1. It could be 1 plus or 1 minus 2i. We'll say we have 1 plus 2i. And the other one we have lambda 1. And just applying the bar, okay, have this just to be the conjugate, where we have 1 minus 2i. And setting up what we have, okay, from the eigenvalues, and we have establishing, okay, the eigenvectors. Okay, so again, we have, in the general case, we have a minus lambda I, matrix of that, we have times v, is equal to 0, and just setting up what we're going to have for our first eigenvector. So you can say we have a minus lambda 1 I, we have the matrix of that times the first eigenvector, okay, is equal to 0. And just, again, for, if we let, it could be its conjugate, but we'll just say we have lambda 1 to be equal to that expression that has addition. So we'll just say we have 1 plus 2i. And so we have, in the setup, okay, so we have 1 minus 1 plus 2i, And so we have ones will go out and have the subtraction over 2i. So we have negative 2i. And we have, in this case, all right, so we have negative 2. You got 2. And for the completion of the second row, we have 1 minus, again, the quantity of 1 plus 2i. So again, we have another negative 2i. And for the first eigenvector, again, we can say we have the general coefficients at a of 1 and b of 1, and representing 0 in the 2 by 1 matrix form. Okay, so we have 0 and 0. And we can just map together. Okay, we'll just do the top row, whereupon we have negative 2ia minus 2b1 is equal to 0. And so we can say that, in effect, okay, so we have, in this particular layout, okay, so we have negative 2ia is equal to 2b1 and so for what we're going to have in the case of, let's say for the first eigenvalue, okay, again we have 1 plus 2i, and let's say that if I have a at 1, okay, so just kind of give you a little idea. Okay, so if I let, just subscript here, okay, so if I were to let a of 1, and we'll say that we have a of 1 is equal to 1, so we have negative I times 1 is equal to b of 1, so you have b of 1 is equal to negative I. So we can say that for our first eigenvector, okay, so if I just allow a of 1 to be equal to 1, and we'll just say that b of 1 is equal to negative I. Okay, so we have, in carrying over, okay, and we need just this one eigenvalue, and I do not have to use the other eigenvalue, okay. And so for what we have in the continuation, okay, so we're going to have in the big picture, okay. So you have, again, so you have x is equal to c times v times e to the lambda t. Yeah, x is equal to c1 v1 times e to the lambda 1 times t. We have x equal to c of 1. Again, for v of 1, I have 1 and negative I. And again, we have with lambda 1. Okay, so that was 1 plus 2i of t. And let me mention, just to kind of adopting what we have from the Euler equation, in case you have e to the 2i times t, and if I factor out the I, and we have, just like from the Euler equation, you have e to the I times the angle, and that's going to be equal to the cosine of 2t plus I times the sine of 2t. Okay. And just kind of carrying over, I'm just going to kind of branch out. Okay, so I'm just going to say I have c of 1 times e to the t and 1 negative I, and for just keeping the e to the 2it, so say we have times cosine of 2t plus I times the sine of 2t. And if I look at distributing, okay, so we'll just say that for x of 1 of t, okay, so I have c1 times e to the t times 1 times the cosine of 2t. And we have plus c1 e to the t times 1 times I times the sine of 2t. And we say we have c1i e to the t times the sine of 2t. And for x of 2, okay, so I have what's going to be negative c1i times e to the t times the cosine of 2t. And we're going to have next in line, so we're going to have c1 e to the t, and you have negative I times negative I. We made that negative I times I. And then we just mentioned, say, have negative I times I is equal to the negative of I squared. I squared is going to be at negative 1. So this will come out to positive 1. So just for what I have in this case, so this is going to be plus c1 e to the t, negative I times I is going to be a positive 1, and we had times the sine of 2t and if I let c1i be equal to c2 in both of these equations, now I'm going to have in the rewrite, now we're going to have for the general solution, you have x of 1 of t, and you're going to have c1 e to the t cosine of 2t. Plus c2 e to the t sine of 2t. And for x of 2 of t, I'm just rearrange this so I have c1 e to the t sine of 2t. And we have minus c2 e to the t cosine of 2t. Now I'll be looking at solving. So this is our general solution. And if I look at solving, what I have for C of 1 and C of 2, again, so we have for the initial conditions. So again, I have x1 naught is equal to 0. So I have x1 naught equal to 0, so we have 0, and I have C1, and the cosine of 0 is going to be 1, so I have 0 is equal to C1. Okay, so looks like for what I have in the case of C of 1, okay, that is going to become negligible. And for x2 naught, again, x2 naught is equal to 4. Okay. So I have 4 is equal to, okay, now C1 is going to go out since the sign of 0 is at 0. And I have 4 is equal to negative C2, since e to the 0 and cosine of 0 will be equal to 1. And it's going to follow that while C of 1 is equal to 0, we're going to have that C of 2 is equal to negative 4. And so for what we will have in the case of the general solution, so we have putting back, okay, so I have C of 1 is negligible, C of 2, okay, we have to be at negative 4. And so we're going to have for the specific solutions, we have x of 1 of t is going to be equal to negative 4 times e to the t sine of 2t. And in the case of what we have for x of 2 of t, okay, so you have c of 2 is at negative 4. And if you notice, we have in the general solution, you have the negative of c of 2. So you have the negative of negative 4. So that's going to be a positive 4 times e to the t times the cosine of 2t. And that will be the solution that we have for this particular differential equations set.